All right, so as promised, we're going to talk about some 5-axis simultaneous this week. So 2 weeks ago, we did the 5-axis positioning. Last week, we did some surface milling, and now we're going to do the 5-axis simultaneous because that is using the surface milling toolpaths and turning them into 5-axis. All right, so this is the first example file. We'll have a few different files to cover a pretty good chunk of the 5-axis stuff, but we're not going to get into all of it just because of time. So the first thing we need to know is that this is has been roughed out, and I have a few different toolpaths to look at. So right now we're going to look at a Z level, doing these steeper areas, and we're going to show the 5-axis tab. So currently I have this set to use something called lead and lean, and I'm going to use contact normal as my from for the multi-axis. So the tool is going to stay normal to it if both of these are 0. So perpendicular to the surface normals. All right, so I want a little bit of a tilt. So I'm going to do a lean, which leans it sideways. So kind of out away from the part, kind of like if you're leaning over on a bicycle when you turn a corner. So we'll do that. Let's take a look at this. I'm going to go ahead and run this in machine simulation. You'll see that I have fixturing and stuff all in here. So here's the UMC 750 Haas machine we used in the last 5-axis video. You can see immediately we've got a tilt. And so we'll go ahead and run through this, and you'll see it's rotating the rotary table, and we're staying normal to the surfaces. So I'm going to speed this up just a little bit. I don't want to get too fast. And so what it does is keeps that tool contact point normal to the surfaces it's machining. So you can see it'll tilt over quite a bit. Let's just go ahead and speed up through some of this section here. It'll take a little bit of time to simulate this. I do have some pretty large step overs to try to reduce this. You see that. Now you see this is tilting way over, and we may or may not collide. It looks like we did okay. We got a lot of motion here as we transition over these edges. And so you see there's a lot of motion there. So that may be one way we want to do it. Okay, another one we could do would be to maybe just turn it over 90 degrees or something and just do it kind of like the 4-axis rotary, but we'll do it on the 5-axis. So that's what this toolpath is right here. So we'll see that we have the same Z level with the 5-axis control. If I tilt this over 90 degrees and say from vertical, so this means when we see vertical, that means like 3-axis. So we're going to tilt from the tool being positioned straight up and down here. We're going to tilt this part over 90 degrees and do simultaneous. So we'll calculate this one now. We'll see that the toolpath now has the table rotate all the way over. So I'm just kind of single blocking this as we go through. So we see we get an entire 90-degree rotation, but if we were to run down, we'll see right in this area where the rotary is spinning and where this little notch in the spindle housing is kind of close that we might run into. So you can see where we're going to run down in here. So I'm going to go ahead and let this go because I want you to see that it does show a collision in machine simulation, which is nice, right? So we'll get down here. I don't want to go too fast because then my graphics card has a hard time keeping up. So we'll just be patient here for a minute and let this do its thing. So here in just a couple more passes around this part, we should see the collision. Okay, so we have the collision. It paused, so clearly I don't have my pause on gouge stuff turned on, so I don't have it showing the dialog. So let me just go ahead and single step that one more move so you can see that it tells us what collided. We also see the kind of purplish pink color arrow showing where the collision is. So we saw that kind of in the turn mill videos as well. All right, so maybe we don't want to quite do that. So you'll notice that I was in here when I first opened this, it was at not 90, and we did like a 75, maybe 80 degrees. And so you'll see it will rotate around here and it will not quite tilt as far, giving us hopefully the clearance we need, right? And so we should be able to clear that now. And if we don't, then we need to get a longer holder or something like that to help us with that. All right, so those are pretty good examples there. All right, now I'm going to switch to a different file. We're going to come back to this file in a little bit. So let me switch over to this fixed example. All right, so fixed is one where we want to basically tilt the tool on a given angle. So this has been roughed out in these openings all the way around. Let me go ahead and just single step this in 3D for you. You'll see that it's been roughed out, and I did took the little result of the simulation so that it starts at that point. And so what I want to do is tilt this tool on one angle, because I'm only going to machine this area in this example. So you see I have a gouge right away, right? So we may continue to have that because I don't have any leads on. Let me just go ahead and hide that for now. We'll just let it go ahead and run. So let's go ahead and run that now that I've turned the gouge stuff off, and let's see the toolpath. And you can see as we're going, we're kind of hitting. We got the pink there showing that we're gouging, right? So we might want to tilt this. Okay, so what I can do is do something called fixed. Now the best way to kind of see this is with a line. All right, so right now when I go in here and go to the Z level and go to the 5-axis tab here, right now it's locked to vertical. That means 3-axis. I want to kind of tilt the tool. All right, so this 0, 0, 1, that is actually the same thing as vertical. So let me show you what that actually means. Okay, so if I were to draw a line from 2 points, just right on my 0, the first endpoint, I'm going to leave it at 0, 0, 0. And I'm going to put in those same 3 values that were in the fixed tab inside those parentheses. So 0, 0, 1, and you'll see I hit create, and that gives me a line that's essentially vertical. So that's the same thing as doing vertical. So when we lock it to vertical, it's 3-axis. When we use the other methods, then we can tilt. So if I were to look at this, if I were to modify this line and go like -1, maybe I want to tilt the tool to the left. So this is our X value. You see it tilts the tool over. If I increase the Z value to maybe 2, you see that changes the angle. We can see the angles changing as we do that, right? So you don't have to get too crazy with these numbers. Just find something that works, okay? So that looks pretty good, but if I look straight down on this, I would kind of need to tilt this back along the y-axis as well. So I'll go ahead and modify this and hit the -1 value on all 3 of those. If I want the tool to be a little more vertical, I could go with like that and get a slightly different angle. So you can kind of get a nice visual using a line. At least that's the trick I use. Okay, so I'm going to plug in those values. They do have to be in the parentheses, so I like to just kind of type over. I'm going to go -1, -1, -2. And I'm going to hit apply, okay? And then we'll just go ahead and hide this. We don't need to see that anymore. And I will go ahead and run this in Machine Sim just because we want to see that. Okay, so I always single step before I run the machine simulation. You see that it rotated the table. It's tilting the table. Okay, I want to hide a couple components here on this, so I'm going to hit the select arrow and just hide these just so I can kind of see at different angles. And now you see that it rotated to get into that position to machine it at the proper angle. Okay, so that fixed one is really nice. Okay, so let's switch over and let's go to from point for a minute. Okay, so this has got a couple different toolpaths. All right, so this has got a Flowline and then a couple Swarf toolpaths. This Flowline is just like what we did in the video last week when I did the Flowline. We have a guide surface and we're projecting out to those faces. So these kind of greenish blue color is what I'm machining. In this case, I actually have the stocks, the actual model set as the stock, so I don't have to do the roughing. And then just give it a negative allowance to cut into the model. So you see it takes a little bit to calculate. Okay, so we're getting into more complicated things. All right, now notice that these parts of the machine are back. I'll go ahead and hide those every time you, go from one file to the next or save your file. They're going to come back. Okay, let's just kind of watch this right now. Now, this is just a 3-axis toolpath. Okay, so I want to introduce 5-axis to this. Okay, so if I go to the front view, I'm going to go up here and show you that I have created a point at 1.5 inches above, and I'm dead center over this, so it's important that it's in the right spot. And I'm going to tell the toolpath to tilt using a method known as other, and I'm going to choose one of these. So ignore the old style. Those are old legacy things from a decade or more ago. These are the improved versions of these. So these are only left here for people that have had 5-axis files from a long, long time ago and they were using the old style just so that it didn't mess with their old files. All right, so what I want to do is say from a point. So what I want the toolpath to do is basically pass through from this point to the surfaces. Okay, so I'm going to make sure I choose the correct point, like so. I'm going to hit apply, and then we'll watch this. Now, the higher the point is, the more vertical the tool will be. The lower it is, the more tilt you're going to get, right? So you just got to kind of figure out the sweet spot. So there is no right or wrong answer for everything. You can create a couple points and kind of experiment, which is nice. So this is going to recalculate that toolpath. All right, so again, I made a change. So just as a reminder, you can hide these. Now, if you didn't want to see certain components, those can be removed from the machine design file forever. But you see now we've got a nice tilt. And we'll watch this from kind of the front. And you'll see the tilt. Let me go ahead and just come down like this view right here, excuse me, and we'll kind of rotate up. So you'll see that this is going to tilt the tool. As we get into the bottom, it's going to start coming more flat. So let's just watch that right here. Sorry for the zooming. So we're going to see the tilt of the table. It's coming back around, and it's going to flatten out towards the bottom. Go ahead and speed that up some. You can see the tilt that I was talking about as we work our way toward the bottom. So it went past from that point through that. Let's watch this Swarf. So this is a Swarf on the outside. It's these orange colored ones. So this is another 5-axis tool or 3-axis toolpath you can turn into 5-axis. So we've got a 5-axis. This automatic generally works for you. And so you'll just go ahead and go with that and make any adjustments if you need it. But generally, it's either going to work or it's not. Okay, so sorry, let's not do the preview. Let's go ahead and do the machine simulation on this. This will calculate the toolpath using the machine as well. All right, so we've got this nice look. Again, I'll just go ahead and hide those pieces, whatever you want to do. Just to make it easier. Again, strip that stuff out, have it stripped out if you don't like it. And we see we're doing a nice swarf. So instead of doing a chamfer toolpath, we can just kind of tilt it over and do that chamfer with the swarf. All right, so the next one I want to do is showing you a swarf that has multiple steps to it. Okay, so I want to step down this wall. We'll do the inner one here. So this has got something called multiple cuts. So in the milling tab, I've turned on multiple cuts. That gives me a Z increment option. I've got a 50 thou here, and we're going to see that using multiple cuts. So it'll step down instead of just going and cutting the entire side of the chamfer like the other one did. So when you have the need to step down on walls, that's how you do it. We don't necessarily need to do it on this part, but I needed to give you an example of that, right? So we'll just kind of watch that. Now we're doing the swarf, and you see it's taking just a little bit. And then we're going to go in here and work our way down. We'll go ahead and speed this up a little bit so it'll go faster after this move. And hiding the pieces, right? pieces of the machine. All right, go ahead and speed that up. Seems to be okay, and we're working our way down. All right, so that's Swarf. Okay, now I want to go show you another one called From a Curve, and then we'll go back to the beginning file. So in this case, I've got this channel. I've got these two faces split. And what I want to do is basically somehow follow this channel and have my tool axis pass through that channel from up above and have my tool tilt towards the surfaces. And I want to work from the top down to the middle and then do the other side and kind of join up in the middle. So I have this as an Isoline toolpath with two different surfaces. So I can choose to kind of go through this because a parallel wouldn't work here because, you know, it just does straight over moves. We need to kind of flow through here with an Isoline. So Isoline will do multiple surfaces, but it treats them as individuals. Okay, so that's going to be treated separately from that one. You can see I have those two surfaces set and the arrow, direction arrow is the way I want it to go, right? And what I want to do is introduce some 5-axis here. And I'm going to use one of these other methods again. And this time I'm going to go from a curve. Now I have a curve and I pulled it off the model. I'll kind of explain to you how I got this. I want this up above because I'm going from. So I want my tool to kind of slide through this, cutting those surfaces, tilting from this curve to the surfaces. Hope that makes sense. All right, so that's the curve I want to use. So I need to make sure I pick it. Okay, and then we'll just go ahead and watch this in Machine Sim. Could do this in 3D as well, but I like to show you the machine. And so we'll let this calculate. And we've gone from a 3-axis toolpath to multi-axis here. So again, let's just kind of hide components. I'm going to switch machines here in a minute, show you a different machine with a trunnion on it. And so you can see how that tool path is tilting. And so just like before, this table will tilt along this axis here as it's going from that curve to those surfaces. So this is a pretty cool one as well. And there's another one I'm not showing. It's from line to line. There's two curves. So if you did a 2, you'd have to point down into something. So there's lines and curves you can use if that makes sense. So we got a nice 5-axis toolpath there. All right, so let's go back to this spindle. I'm going to go ahead and switch machines now. Click in the right spot and go to a vari-axis for Mazak. Let's go ahead and switch to this one. All right, so this one is a surface mill to a point. So if we look at it right now, it's set to vertical. So let me just show you, again, that just is a 3-axis toolpath, right? And if we do that, then we're going to likely have a collision with the tool and the holder or something, right? So you can see that's coming pretty quick. I do have the gouge checking off in the simulation thing. So you see the pink is showing, hey, we're hitting. Okay, so we want to tilt that, and we could try to do like a lean or something and tilt it over sideways, but maybe we want it to tilt, tilt over quite a bit and have a variable in that lean, as it were. So you'll see that I've got 2 points right here that I created. You can actually use these cylinder centers from the surface on the model, but I'm going to start with this one. So I'm going to go to a point. Now, the lower that is versus the higher the point, it's going to change our angle, right? So I'm going to go to a point, and I'm going to pick this one right here. So the lower that is, if I'm going to that point, it's going to keep the tool more vertical and may not give us the clearance that we need. So let's go ahead and run the machine simulation on this after it calculates this tool path. Again, single stepping to kind of get it loaded. So there's our roughed out part. Go ahead and slow this down a little bit. Okay, so kind of see it tilting. So this is a machine with a trunnion across X instead of the Y axis like the other one. So as we work our way down, we can see we get the tilt. Okay, now that we're getting some tilt, I'll go ahead and slow it down a little bit so you can kind of see that motion. And you can see I'm also kind of missing some of this, so I may need to tilt this tool a little more. So that means I need to point from a higher point, or go from, or excuse me, to a point that's higher in Z-axis to give us a little more tilt maybe. All right, so let's go ahead and hide this component. All right, now this spun away from us, right? So the table, the trunnion came towards us and the part went away from us. So just as a reminder, the setting for that is the alternate 5-axis positioning thing we talked about in the video a couple weeks ago. So let's go ahead and watch this now. I'll redo this and then we'll do the last one where we can try to keep the tool vertical and just avoid gouges. All right, so you see this now, it's tilting the trunnion the opposite way overall. So it did kind of jump back and forth a little bit. It's now bringing this around to us this way. Okay, but let's change the point, right? So I mentioned that we wanted to get a slightly different tilt. So we're gonna switch this to that point. I'm gonna go to this Z level and I'm gonna choose a different point. It's gonna change our angle. Okay, so you saw how that was tilting over quite a bit before. Let's see if it tilts over as much. So we'll calculate this new toolpath. And as you can see, it doesn't take a terribly long time on this part to calculate it. Okay, now the one thing I didn't do on this is probably set the alternate. So let's see if this flips over again like the other one did. I'll go ahead and speed this up. Yep, and there it goes. So at some point it wants to change the side that it's tilting, so it's going away from us. So we'll go ahead and go alternate with that one again. Maybe standard with this. Oh, that was the same toolpath. My bad. Let's watch it. We'll see what happens anyway. So I may need to put that back, but I didn't let it finish. But we'll take a look here. Okay, so it did start that way. Let's see if it comes back this way. So really depending on the point you pick, it may or may not, or may have an effect on whether you need a new standard or alternate. Again, I've got pretty large step overs just so our simulation doesn't take a while. But you see there's kind of that happy medium at some point to get the simulation to work. But now you see the tilt is not quite as much as we work our way down this part. Okay, so that might help us avoid a collision as well, right? So we got to worry about this here. So let's see if we make it or not. I'll go ahead and just go to this right view and zoom out. Yep, and we're colliding, but I have it turned off, so we're not seeing it, right? Okay, so the other one was a little better. Okay, so you need to experiment with your points, as I mentioned. Okay, so the last thing I want to do is show you this where I'm going to keep the tool vertical as long as possible. While I'm thinking about it, I'm going to go ahead and go to alternate and see if that's the answer for this. Okay, but what I want to do with this is I want to keep the tool vertical for as long as possible. And what I want to do is introduce something called gouge avoidance. So the default is to do no tilting. So if I were to go vertical with no tilting, that tool is just going to be a 3-axis toolpath. We already know what's going to happen. We did that on the first one before we put on a lean, right? We're going to hit with the holder. Okay, so what I want to do is give it an option. And you can see there's a ton of different options. So I could use one of these points to point towards or whatever, some of these other things we've talked about. Or I could just do a simple lean and say, hey, why don't you just automatically lean over? And so it will just determine that based on a couple things I'm going to show you in a minute. We could do a lead. That's where the tool tilts forward or backwards. So think about like if you were riding your bike or running around a track. When you start, you're kind of leaning forward. When you go to start running, right? That's called lead. And then if you did a negative, that would be leaning backwards. So that's a negative lead. Okay, and lean is side to side, like going around the corner, right? So I could do that, Or I could even do a combination if one of these didn't work, and say, hey, try leaning first, and if that doesn't, then lead, or the opposite. But usually a lean will help you, especially on this. I expect that to be okay. So this is going to do it, but it's looking at a couple things. So we need to see what those are. So we have a shank and a holder on our tool, right? And so there's a shank clearance value. So that gives you a distance to clear the tool shank. So if we get close to the shank, it's going to lean because that's our rule. We also have a holder clearance. And you can see the defaults are 50 thousandths on the shank, 100 on the holder. You can do whatever you want and do that, right? So I usually just go with these. That gets us kind of close. So let's take a look at this one now. So I'll just go ahead and start this from the front view, single step to get the machine loaded again. Let it calculate this now. So this may take a little bit longer to calculate as it's taking a look at the tool holder, the shank, against the model and all that. All right, so let's go to the front view here. And let's just kind of watch the magic happen here. Okay, so we see it's staying vertical. So we have no 4 or 5 axis motion going on right now. That's going to be great for rigidity. We could even maybe shorten up this tool in the holder, right? So this is going to remain vertical as long as possible. I'm going to try to catch it here. There we go. Let me slow this down now. And you can see it's automatically tilting to kind of avoid that. So we'll hide this again. And so it's doing the lean like we told it to clear those things and avoid that, right? So it looks like standard was going to be the answer again if we wanted the part to tilt towards us. I chose alternate. We can see that's going the opposite way. So quickly I could just go make that change, right? Or you could watch it machine like this, however you want to do it. Just as one last reminder, in the milling tab, I'm going to go back to standard. So you really need to just watch the toolpath. So alternate was an answer only on one of those scenarios. Seemed to be standard was the answer on the others. Okay, so recalculating here takes just a moment. And we'll watch this. So tool staying vertical as long as possible. And then it's going to do the avoidance and start tilting and working its way down using lean. Because that was the option I gave it, right? So now we're all the way down here. We've machined this part multiple different ways. That's the 5-axis simultaneous. Let us know if you want to get into FeatureCAM and get using this stuff. It's really powerful, and we can get you trained up and get you going. All right, thanks for your time, and I'll see you next time.